Okay, hello, my name is Arwen, and in this video we'll be talking about instantaneous rate of change versus average rate of change. So average rate of change is the slope of a secant line, while instantaneous rate of change is the slope of a tangent line. An average rate of change will usually be between two different points, which you can see here in the equation, while instantaneous rate of change is the slope of like 1 point. And this is the equation for instantaneous rate of change. And so an example problem would be that, find the average rate of change of negative 2x squared plus 1 from x equals 4.5 to x equals 5. So the first step here would be to find what the y value is for 4.5 and 5. And to do that, you would put out negative x2 plus 1, and you would plug in the negative 4.5. And then you would solve from there. And then this would be your y value for 4.5. And then now we're going to be finding x equals 5. So we do the same process again. Okay, and that is the y value. And now you just kind of plug them in. And you would then kind of like plug them in. So FB, which would be the negative 49, you write that down. And then since negative 39.5, since the equation already has a negative here, you would make like a separate parentheses and add the negative. Now you add the b minus a, so 5 minus 4.5. Which would give you a final answer of negative 19. And then now to solve for instantaneous rate of change. So in the problem here, find instantaneous rate of change for f of x equals negative 2x minus 1 at x equals 5. So from here, you would have your equation set up, which you would plug in values. And so for this, you would do the negative 2 times the x plus h. And then don't forget the squared, minus 1. And then for the f of x, you just do negative, and then you plug in the equation itself over h. And so it's x plus h squared. So x plus h, x plus h. And so to get that, you get x2 plus xh plus h2. And then you'd solve regularly. So now you do the negative x2 plus, the minus 4xh minus 2x2 plus 1 plus 2x2 minus 1 because you distribute the negative. And, oh yeah, this is supposed to be plus. Sorry about that. Over h, and then now you cancel out values, so you have 2x2, 2x2, and then you just get left with negative 4xh minus 2h2 over h, and you want to kind of separate the h in order to get rid of the denominator. Like this, and to give you negative 4x plus 2h, and then at this point you want to plug in 0, which would just cancel out the 2 and leave you with negative 4x, which then you plug in the 5 up here. So negative 4 times 5 is equal to negative 20, and you'll notice that from the average rate of change to instantaneous rate of change, they're like one apart from each other. So that's a good way you can spot the difference. And well, that's the difference between instantaneous rate of change and average rate of change.